Tak, už jsme zpátky. Oleg už je připravený, takže hi Oleg.
Hello, thank you for bringing me here.
Thanks for joining us today. And Projector, what it is and how it works.
Yeah, let's start. So my name is Oleg Chirukhin. I'm product marketing manager at JetBrains. And my first disclaimer is that English is not my native language and we have just 15 minutes, but I will try my best. So we will talk about Projector. I can promise that in the next 15 minutes we will learn a few things like what is Projector, how to use it, and what is the Projector system architecture so that you can contribute to it and adapt to your needs. We all need remote development sometimes. Imagine that you have a powerful desktop computer at work, and then you usually run IDE on that computer. You want to use it from home, or you want to use a lightweight laptop to run dozens of Docker containers on some MacBook Air, or you want to work on a tablet like iPad Pro. It's convenient to use your powerful remote computer for many reasons, like indexing works faster on it, everything compiles faster, and so on. And it's convenient to use remote data storage to avoid copying of terabytes of data to your home laptop. And this is especially useful for people working with big data. So you already know how to do this. You can run VNC or RDP and broadcast your screen over the network. But all these solutions have their own problems. For example, VNC is pretty slow, and RDP is faster, but it is single user, and it has issues with Linux clients. And in both cases, when the network speed drops, you see an ugly, blurry picture on which it is difficult to read fonts. So both VNC and RDP require complex infrastructure, and usually you need to use a VPN to connect to them. And of course, you can run IDE on your computer and connect to data remotely via VPN, but VPN needs to be configured, and it's not very convenient, and indexing files via VPN will be not very fast. Some other proprietary solutions also exist, but I will not cover them in this talk. So, Projector. We have invented our own remote work solution called Projector. It's very similar to VNC or RDP, and it allows you to broadcast your IDE window over the network. And not only the IDE, but in the future, any application is written in Swing framework for Java. So you can run the IDE in a specific way on the server, like your powerful desktop, and then connect it to it from the browser or using a client app, and it just works. Cons compared to VNC and RDP, it does only one thing. It projects only JetBrains IDEs like IntelliJ IDEA over the network. And pros, it does this one thing very well. Like rendering is high speed and all fonts are perfectly sharp because they are own vector fonts. And Projector is open source and free as a freedom, and Projector server is published under GPL license, so like Richard Stallman would be very delighted. And that's all. We can finish this talk, or not? Because maybe you need to understand how it works. So, Swing app. Let's take a look how a typical Swing app application works. Basically, it is visually no different from any other GUI application. You have a window, and inside the window there are all kinds of controls like buttons, input fields, pictures, and so on. And this interface can be as complex as you like there can be dozens of buttons. As simple developers, we think about this application at a high level of controls, all these buttons and input fields. But Java graphics engine thinks about the application in a slightly different way. For the graphics subsystem, reality looks like a collection of lines, simple shapes, fonts, and so on, and it is very low-level presentation. In general, the architecture of Swing application looks like this. The root and main element for us is the toolkit. This is an abstraction for all the graphics, and each operating system has its own operation of the implementation of the toolkit. And if you look in more detail, the framework operates with two types of components, heavyweight and lightweight. So heavyweight components are controlled by the operating system, and this is some kind of physical representation of all our controls in the operating system. And lightweight components are controlled by the framework itself, and they are drawn on top of the heavyweight components. So the difference is that if your operating system only knows about orange buttons, then only orange buttons can be made using heavyweight components and nothing else. And lightweight components can look whatever you want. For example, you can simulate the appearance of Windows XP or Windows 10 or KDE, whatever. So Java even has its own skins for designs called look and feel. And if you remember the name like Nimbus, that's it. From the Java perspective, each heavyweight component has its own representation entity called peer. And from the point of view of the operating system and system-level C++ JDK code, peers are implemented in JDK as a native code, and we don't need to know how they work. It's like magic. But from the Java code point of view, very complex language, English, you know. So peers look like this, like on the slide. So it consists of 3 data setters, and all calls in it delegate drawing operations to something called graphics2D, graphics on the screenshot. So what if you want to draw all of this in a browser? So we need to re-implement this entire graphics subsystem, but by ourselves. So we need to replace toolkit, we need to implement heavyweight components, implement our graphics2D on top of canvas in the browser. And at the same time, better to simplify the work as much as possible so that you don't have to write half of the JDK yourself. ABT and Swing work slightly different on different operating systems, so we decided to implement only a subsystem for Linux for now. And that's why Projector only works on Linux on a bare operating system. And if you want to use Windows or Mac, it needs to be run in Docker or WSL, unfortunately. So there are many different heavyweight components. So we simplified the work by implementing peers only for what is really needed for JetBrains IDEs to work. So absolutely any application will have at least one window, one panel, and we have implemented all of them. And different peers also exist in our code, but they have empty stub implementations, methods that return int in such fake implementations. They always return 0, and methods that like return void, they do nothing, and so on. So. And the final part is graphics2D. So graphics2D is, it looks like on the slide, but in this class we must implement as much as possible to work fine in the browser. And the drawing comments on the top of our version of graphics2D do not draw on the screen, but on the HTML5 canvas in the browser. So implementing this was not so easy. For example, the first implementation in browser runs at 5 FPS, and those who play computer games should understand that 5 FPS is very slow. And therefore, we came up with a set of tricky optimizations. This is how organized, so that each component is assigned to its own message queue. And the queue looks like this on the slide. So inside it has a builder into which we can put almost any sequence of graphic sections and optimize over them. So the most tricky part is images, because they are not in vector format and still they must be transmitted over the network. And it turns out that we have 5 types of images in Swing, and we implemented only 3 of them. And the simplest is the Volatilelmage, which is used to display like off-screen surfaces, and it is rendered using render primitives, and they are sent as a separate command, so that's easy. But the next step is Bufferedimage, which must be sent as a bitmap. And in order not to send images again every time, we cache them. And to do this, we use an utterly wild heuristic that tries to understand whether the picture has changed or not. And images have a very complex hash function. It goes through all the pixels and sums them somehow in hash function. And it takes a long time. So we do hashing using like a private undocumented APIs in JDK. It hurts a lot, so don't try this at home, but it works. So, but nevertheless, now it is very easy to find a wagging picture that is too big, but in the future we will try to optimize this too. So, and the creepiest part is the multi-resolution image. They are used to draw something like toolbars, yep. When the toolbar is zoomed in, the image is not scaled programmatically. Instead, another picture of a larger size is loaded from the resources. And surprisingly, most of these images like in real-world applications, they display only a single resolution. So it's strange and surprising, but it is a fact. So we saved some effort, and our version of multi-resolution image can only work with one resolution. So other types of pictures are not supported at all. So if someone tries to draw them, they will get nothing. They will get an empty area. And fortunately, they hardly ever appear in real-world applications. So the main loop on the server looks like this, like on the slide. This may seem pretty lame, but in fact, many graphics engines do that, like Google's Filament, which runs inside Android. And we could try using schedule to thread pool, something like that, but this might be a more unstable solution, since we would have to resolve thread overlaps and all this system-level stuff. Send all commands function here. It collects all draw events from all the queues. It collapses the duplicated and unnecessary messages. It collects all images. It compresses them and sends over the WebSocket. And on the other side of the WebSocket, all this is displayed in the browser. So as a default network message format and protocol, we use hand-optimized JSON. This is how it looks on the slide. And you can see all fields are single letter. So this allows you to spend less traffic and parse the protocol faster. And this is a wild optimization from like a dark era of technology. If you were a web developer in the early days of Ajax and JavaScript, then you've probably seen all the stuff all the time. Other formats can be used too. For example, protobuf, anyone can write their own format, whatever, but JSON is too good to abandon it, actually. It's very fast. So on the backend, you're probably used to the standard set of web servers for the JVM, like Cater, Tomcat, Undertow, Native, Jetty, Resin, Glassfish, Wildfire, and so on. So the problem is that the Projector server part is derived from the OpenJDK code, which means it is licensed under GPL2 with cross-path exception. And all these servers are published under the Apache 2 license, which is incompatible with GPL2. However, writing a WebSocket implementation by ourselves is quite difficult, and therefore we use a server called Java WebSocket, which was published on the GitHub by GitHub user ToTallNate. So the only problem is that the server does not support HTTP, which we need to serve static files. And the author, ToTallNate, I mean, he doesn't want to add the support. And we understand why, so we had to come with a hack. There is concept like code drafts supported inside the server, and we have implemented a draft for HTTP protocol by ourselves. And maybe it works, who knows, it mostly works. So clients, we have two clients, a browser and desktop. And in fact, the top client is Electron, so it has always been a browser. To implement such a client, you can do it yourself. You need to implement about 30 drawing operations for all kinds of primitives, lines, circles, etc. So it's not very difficult because HTML5 canvas can do everything already, and any decent graphics engine like Unreal or Unity, etc., Godot, they all can do all this graphic stuff. We are writing client and server in Kotlin, making it very convenient for us to share the code between the server and web interface. It is not necessary to write the parsing of the network protocol twice again in different languages, because there is only one language, and it is Kotlin, remember. So, thanks to the fact that we have Kotlin, we can easily add existing protocols implementations as dependencies. For example, we can use our highly optimized JSON, but also we can use Kotlin X serialization, which is much nicer but slower, and we can use protobuf, which uses less traffic but puts more CPU load. And CPU load is essential on mobile devices, such as tablets if you want to code on iPad. You don't want high CPU usage. So, and to avoid shortcut conflicts, keyboard shortcut conflicts between the browser and the client, we made a desktop client based on Electron. And in addition, it allows you to do several convenient things, for example, full screen on Mac. And deployment options, we have 3, like a Python script, Docker, and a plugin inside the IDE. The main method is considered to be a Python script. It's straightforward to use. You run pipx projector installer, and then a wizard will appear in the console and will guide you through all the steps, like how to select port, how to choose what IDE you want to run, and so on. So, and Docker, you can build a Docker image yourself from Docker file on GitHub, or download a ready-made image from our own Docker registry, which is not Docker Hub, by the way. So we plan a lot of different improvements, like support for Asian languages, bug fixes of visual glitches. We have them, unfortunately. More AVT components, high DPI, speculative typing. Speculative typing, it is when you can write text and the letters will be displayed before the server responds. We will write native clients for mobile platforms. We will optimize everything, and actually we can do anything we write in our issue tracker called utrack. All contributions to this project are very welcome. All code is distributed under open source and free licenses. So server are under GPL2++ exception, like OpenJDK. Client is MeetXpat, and Docker files are Apache 2. So while licenses are different for a reason, we tried to find a combination that would work for a variety of applications. So if you want to try to participate in the project, that will be very good. You can add features, you can fix bugs, you can do something big like writing a completely new client, and so on. So all links are on our website, like Projector JetBrains.com, and there you can download everything you need to use, and there you can find all the GitHub's links, and so on. So that's all. Thank you for attending this talk, and questions.